Hi, welcome back to my channel, and for today's video, we will talk in one of the celebrated topics of Calculus 2, I guess, in some universities, about the sequence and its convergence. Okay, so let's start now. We will start first with definition. So a sequence function is a function from the set of natural numbers to the set of real numbers. Ibig sabihin, we have this here. So yung domain natin dito, lahat mga natural numbers. And then, the output are elements of real. So, kumbaga, may mapping ka dyan. So, meron kang paganito. Okay. So, anong message ng definition na to? Ang sabi dito, the sequence is the ordered list of elements of the range of the function. So, ibig sabihin, when you have natural numbers coming from your domain, tapos namamap siya, so yung mga range na yon, they are actually the sequence. And take note, it should be ordered. So, this sequence is actually infinite. Yung naka-order na mga sequence dito, they are called terms. So, ibig sabihin, kunyari, your function, yung input mo from your domain is n. So, yung lalabas niya is a sub n. So, this is the n term of the sequence. Yan. So, for notation-wise, if you have the a sub n and from 0 to infinity, kasi nga, we're actually getting a set of natural numbers. So, kasali si 0 nun. So, ang mangyayari dito, this is actually a sequence. A sub 0, A sub 1, until A sub n, and so on. Pag wala namang ambiguity on the sequence, you can just write as A sub n. Yun. Okay, let's consider, for example, let's say you have un. So your un is defined by u sub n equals, let's say, u sub 0 plus d times n. So yung d mo dyan is not 0. Okay, so let us say, for example, let's say you have un n from 0 to infinity. So, ang mangyayari dyan, this is equivalent. Let's say, yung laman is 3, 5, 9, 11, and so on. So, ang mangyayari dyan, you take into consideration that u sub 0 is 3, your d is 2. So, ibig sabihin, kung kukunin mo, using this definition, kung kukunin mo yung u sub 20, ang mangyayari doon, you have 3 plus, yung d mo is 2, yung n mo is 20, so you have 43. Yan. So this is a sequence. In fact, we call this in high school as arithmetic sequence. Okay, another example. Let's say your un is defined by, let's say, un equals u sub 0 d raised to n. So yung d mo again is not 0. So we have example as, let's say, 3, 6, 12, 24, and so on. So anong ibig sabihin nito? This means that your u sub 0 is 3 and your d is 2. So if you're interested to get, let's say, u sub 20, yan. So what happened is, your u sub 20 will be 3 times 2 raised to 20. And the answer will be your 20th term of the sequence. So this is actually one of the famous sequences then. In fact, in high school, we call this as geometric sequence. This one, in high school, they call it as common ratio. Yan. That's it. Okay, another example. Let's say we have u sub n, and our u sub n is defined by u sub n equals u sub n minus 1 plus u sub n minus 2, where your n is greater than or equal to 2 and your u sub 0 is 1 and u sub 1 is 1. So, ibig sabihin, the sequence would start as 1, 1, kasi magsisimula tayo sa 2, di ba? So, ibig sabihin, meron tayong u sub 0 kasi ito yung pinakamababa. Okay, so that means u sub 0 is 1, u sub 1 is 1, u sub 2 is 2, u sub 3 is 3, and then next is 5, next is 8, next is 13, and so on. So parang nag-a-add kasi ng mga previous two terms. So this is one of the famous sequences then. In fact, it is called Fibonacci sequence. Now, in this video, we're actually interested about the behavior of our sequence. So, kunyari, yung sequence mo is an. So, this is defined as 1 over n squared. And that's n from 1 to infinity. Kunyari, ganyan. Let us try to examine what happened, what's the behavior of the sequence. So, kunyari, your n is 1. So, what happened to your a sub n? So, if this is 1, so maging 1 yan. But when n is 10, maging 0.01. Correct me if I'm wrong. If this is 100, this is 0.0001. This is 1,000. Ang mangyayari, this is 0.000001. Correct me if I'm wrong with my computation. Pero yung tanong ko lang, what is then the behavior of the sequence? So kung titingnan mo, habang papalaki yung value ni n, yung a sub n mo papalapit to 0. Tama? So this is actually the intuition behind the limit of a sequence. So this means that the limit of an as n approaches infinity is 0. So ito yung intuition explanation of a sequence. Kaya when I teach this a lesson in the version of functions in Calculus 1, I always inform my students, don't think a limit of a function is a substitution because it's technically not. Some theorems would actually tell that it could be a substitution kasi meron naman talagang mga cases na ganyan, pero not at all times. So I am actually giving you a message that don't think that a limit is a substitution. Okay, so let's formally consider the formal definition of this intuition. So let an be a sequence and L be any real number. Okay, so the limit of an is L if and only if for every epsilon greater than 0, there exists capital N greater than 0 such that your a sub n minus L is less than epsilon for all n less than a small n, and that small n is a natural number. Okay, so yan yung definition ng ating limit of a sequence. So, if the limit of the sequence exists, so ibig sabihin, if the limit of these exists, we call that as your an is convergent. If it doesn't exist, then we call that as divergent. Yan. So, this definition is actually powerful because this will be used in order for us to determine if the given value of a real number is a limit of a sequence. So parang papatunayan natin sa buong mundo na this is the limit of a sequence. So let's say for example, number 1, kunyari yung sequence mo is 1 over n squared as n from 1 to infinity. So ito yung kanina, di ba? Kinuna natin ng intuition at nalaman natin that the limit is 0. So, paano natin yan papatunayan that this converges to 0? Kasi alam natin convergent siya. Pero bakit? So, that is one of the fundamental questions of this video. Okay, so before natin ipoprove yung example na yan, we will have to take a look into consideration first on the definition. We will have a basic parang konting algorithm lang on how to do that. So number 1, by virtue of this definition, we declare your epsilon. So your epsilon dito is greater than 0 because ito naman talaga yung message ng definition eh. Number 2, you declare your n. Your n should be greater than 0, but this is dependent on epsilon. So dependent siya. So if you are declaring your n, so that means if n is an element of natural number, ito yung sabi dito, yan, this one, with n greater than or equal to n, then meron ka makikitang n na may inequality relationship with epsilon. Kasi, after that, you manipulate this sequence. Ganyan. Let's try to prove this one now using the algorithm. So number 1, sabi dito, declare the epsilon. So you let epsilon be greater than 0. And number 2, we declare the n. So we choose n. Yung n mo is alam mo greater than 0 and it's dependent on the epsilon. However, di natin alam ano yung equivalent niya with respect to epsilon. So leave that as blank muna and then we will have to go back to this blank space para if fill in natin yung makikita nating adjustment niya. So if n is element of a natural number with n greater than capital N, then ano nga yun? Meron tayong relationship ni n with respect to the epsilon. Ang problema lang, hindi pa rin natin alam. So, leave muna natin ng blank. And so, blank. Ito yung parang conclusion dito. Yan. Okay. Thus, for n element ni natural number, so any natural number n with n greater than n, pwede mo nang hindi ito isulat kasi nakasulat na yan sa taas. So, manipulate na natin to. So, you have 1 over n squared. Yung L natin is 0. So, pag ganun, and this is equal to 1 over n squared. Tama? Alam natin kasi si n, it's a natural number, so it's greater than or equal to 0. And so, if I take the square, automatically positive talaga siya. So, pwede na natin tong tanggalin. Okay. So yung goal natin magiging less than epsilon siya. So may idea na tayo. Dapat kasi yung 1 over n squared mo is less than epsilon. Scratch lang to ha. So magiging 1 over epsilon is less than n squared. Okay. And so, pwede nating lagay dito that 1 over epsilon, unahin ko munang ilagay si n. So n is greater than 1 over epsilon, n squared yan, para pag swap nila, ito yung lalabas. So, ito na siya. Epsilon is greater than 1 over n squared. Para pwede natin itong gamitin dito. So, this is less than epsilon. And so, ano yung adjustment natin kay n? So, si n pala, since si n natin is greater than this capital N, ito pala siya, 1 over square root of epsilon. Nagets ba? Kasi para, di ba alam natin this is n greater than capital N. So, ang mangyayari, n is greater than 1 over square root of epsilon. So, take the square of both sides. So, n squared is greater than 1 over epsilon. Di ba? Yan yun. So, since na-build na natin yung argument na yan, then, na-prove na natin na totoo yung claim. So, therefore, an converges to 0. And so, it's convergent to 0. So, that is, yung limit niya as n approaches infinity is 0. That's it. Let's try another example. So, you have 1 over n squared plus 1. So, alam natin that from n equals 1 to infinity, or kahit 0, from 0 to infinity, this converges to 0. So, i-prove natin na totoo yan. Sige nga, using the definition, let's say, let epsilon be greater than 0, and you declare your n. So, and we choose our n, which is equal to something we do not know yet, such that if your n is a natural number with n greater than capital N, we have n na may relationship dyan with respect to epsilon. Thus, meron kang result dito na parang conclusion dito. So, mangyayari, So hence, in 1 over n squared plus 1, this is minus 0. So this is equal to 1 over n squared plus 1. Kasi alam natin magiging positive lang naman to. So gagawin na natin ganito. Pwede na natin tanggalin yung absolute value. And so, alam natin this is less than 1 over n squared. Sure tayo dyan. And then 1 over n squared, alam natin this is less than or equal to 1 over n. So gusto nating magiging less than to sa kay epsilon. So ibig sabihin n is greater than 1 over epsilon. And so, epsilon is greater than 1 over n. So pwede natin itong ilagay as epsilon. Yan. So na-prove na natin. So therefore, your an converges to 0 as n approaches infinity. And so, your limit of your an approaches infinity is 0. That's it. Okay, one final example for this video. So let's say our sequence is 3n plus 2 over n plus 1 as this one converges 3. Okay, so paano yon? Yung proof natin, let epsilon be greater than 0 and we choose n be equal to something we do not know yet, such that if n is a natural number with ano yun, n greater than capital N, then we have n na may relationship siya to epsilon, and thus this is the conclusion there. So paano natin yan laruin? Manipulate natin 3n plus ano nga yun? 3n plus 2 over n plus 1. So yung ini-expect nating limit niya is 3, so minus 3. So pag i-compute ko to, magiging 3n plus 2 minus 3n minus 3, tama ba? All over n plus 1. And so this is, ano to? Cancel sa 3n, so this is negative 1 over n plus 1. Pero if tatanggalin ko yung absolute value, this is actually 1 over n plus 1 lang naman. Okay. So what happened? Alam natin this is less than 1 over n. Yan. And so this is less than epsilon. So the adjustment pala is 1 over n is less than epsilon. So this is greater than 1 over epsilon. And so this is 1 over epsilon lang pala. So therefore, your an converges to 3. And so the limit of 3n plus 2 all over n plus 1 as n approaches infinity is 3. That's it. So that's all for now, guys. Thank you so much for watching. If you have any questions or clarification, please let me know so that we can discuss on that. And for those who are new to my channel, please don't forget to subscribe so that you'll be updated on a lot of videos that I'll be uploading soon. Thank you and bye for now.